For the I can statement, it's I can describe the properties of a figure before and after a translation. Example 1. Find the image of a translation. So for this example, we are being asked what is the graph of t, which is the transformation, 7, negative 4. The 7 means that we're going to go right 7, and the negative 4 means we're going to go down 4 from the original image. So E is going to go to the right 7, which ends up being here. Oh, I'm sorry. But then we also have to go down 4. So from that point, we go right 7. 1, 2, 3, 4, 5, 6, 7. And then we go down 4. And that puts us right here. And for F, we're going to do the same thing. We're going to go right 7. We're going to go down 4. That puts us right here as our F prime. And I'll go back and label the purple dot E prime. And then for G, we're going to go right 7. We're going to go down 4. And that's G prime. Then what we're going to do is connect those dots. And that is our triangle after the translation, 7 to the right and down 4. Hello geometry students. Today we are doing lesson 3-2, translations. Please put your name, date, and period on your paper. The essential question for today is, what are the properties of translations? Your vocabulary today, vocabulario, is translation, traslación, pre-image, pre-imagen, image, imagen, composition of rigid motions, composición del movimiento rígido. For example 2, it asks us to write a translation rule. What translation rule maps P, -3, 1, to its image P prime, 2, 3? So to get from the image P, we are going to go right, and then we're going to go up. So we went right 5, +5, and we went up 2. And the first number in our translation is going to be left or right or left. And the second number is going to be up or down, depending on if it's positive or negative. So the translation rule, if we go back to example 1, we're going to put that in brackets like so. We put a T in front of it because it's a translation. And that's going to be of P equals P prime. That's what we do for writing a translation rule. All right, let's turn our page to the back. And we're going to do another translation rule. So to figure this out, we want to know what is happening to each coordinate point. So if we started at S, we would go left 1, and we go down 4 to get to that next point, S prime. And let's see if that works for all of the points. We start at T, we go left 1, down 4. For U, we go left 1, and we go down 4. For V, we go left 1, we go down 4. So how do we write that as a translation rule? I said left 1. Remember, left or right is our first number, so left would be a negative. And then we went down 4, so that would be also a negative 4. Put it in the arrow brackets. It's a translation, so we use T, and it was of S, T, U, V equals S prime, T prime, U prime, V prime. And that's it. Example 3. What is the composition of the transformations written as one transformation? For this, you just have to combine the x's, or like the left-right numbers, with the up-down numbers. So the 3 and the 1, that becomes 4, right? Because if you go right 3, but you're also going to go right 1 later, then it's going to be a total of 4. And then we went down 2 and down 1 for a total of down 3. So the composition, like if we put them together, is just this. T bracket 4 comma negative 3 bracket. All right, for part B, same concept. So we have negative 4, so that would be left 4 and left 2. So that'd be a total of left 6. And then for 0, that means we wouldn't go up or down, we just stay, but then we also go up 5. So this is our composition, T bracket negative 6 comma 5, for that composition of transformations. Example 4. Relate translations and reflections. Suppose n is the line with equation y equals 1. I'm just going to graph that. Where is y equals 1? Well, this is the y-axis. This is the x-axis. So y equals 1 is right here. And then we just draw the horizontal line through that point. Given DEF with vertices D00, so I think I'm going to plot these, E03 and F30, what translation image is equivalent to, and this is the reflection over N, and this is the reflection over X axis, which means we're going to do 2 reflections. All right, let's plot these points. We have 0, 0 right here. We have 0, which means I don't go left or right, 3 right here. And we have the point F, which is 3, 0. And just label these F and D and E. And then I will connect these points. Okay, so what they're asking us to do is to reflect over n, so this is line n, and to reflect over the x-axis. So we're doing two reflections. But it's backwards, so actually we should reflect over our sub x first. So we're going to reflect over the x-axis first. And since D and F are already on the x-axis, they're not going to move, but E is 3 away, so E is going to come down here. And we have that triangle, and now we're going to reflect that triangle. Change my colors. We're going to reflect that triangle over line N. So right now, D is 1 away from, like right here. It's 1 away, so it's going to be 1 away. It's going to be right here. I shouldn't have drawn that blue because and now I erased my whole line. Okay, so to reflect over line N, I'm reflecting the purple triangle over line N. So that will put D right here because it's going to be 1 away. It's going to put E, the purple triangle is 1, 2, 3, 4 for my E away. So this was E prime. It's going to be 4 away from this line. So 4 away would be up here. That's going to be E double prime. And this was D double prime. The F was just 1 away, so it's going to be right here at F double prime. And we get this triangle. So what they are trying to show us here is that if I do a double reflection over the same line or a parallel line, because X was parallel to line N, see how those are parallel? If you reflect twice over parallel lines, then it ends up just being a translation. So I could have just taken the red triangle and moved it up 2 units. And that is summarized for you right here in reflections across parallel lines. A composition of reflections across 2 parallel lines is a translation. So right, I did a composition of reflections over 2 parallel lines and ended up with just getting a translation. The distance of the translation is twice the distance between the reflection lines. Oh, okay, so if I look at this distance between these 2 lines, it's a distance of 1, and I moved the triangle up 2 spaces. So that's kind of interesting. The distance of the translation is twice the distance between the reflection lines. And there's a picture of this right here. So they, in this case, they reflected A, B, C, D. They reflected it over this line, and then they reflected it over a parallel line. And the translation ended up being double this distance. And that is your notes for today.